Welcome back to another design and implementation video. This video covers a very important topic that is somewhat universal to the degree at QUT, and this topic is source control, specifically alongside using Unity, employing the use of Git, Bitbucket and SourceTree. This video will aim at describing what exactly the purpose of this software is, how to perform some of the more basic operations within it, and how we can set it up to most efficiently be used alongside our Unity projects. So first of all, let's talk about what Git is. People often misuse the terminology regarding source control, describing Git as GitHub, referring to similar technologies, or simply referring to the program they interface with as their repository. This can be confusing for folks trying to work alongside them in the same team, so let's make some sense of it all. Git can be best described as version control software and protocols that may exist on a host service to keep track of your software development projects. A competitor to Git would be something like Mercurial. GitHub is a project data storage service that allows you to host your Git repositories. GitHub is therefore not the same as Git, but a natural extension of the use of the software. A competitor to GitHub would be Bitbucket. By default, Git is a command line software-driven application, which is too clunky and confusing for most users. SourceTree is a GUI application that allows you to interact with your Git repository through the host of your choosing. SourceTree is capable of connecting to various Git or even Mercurial repositories through a variety of different hosts. Unsurprisingly, it is where most folks spend their time manipulating source control elements. An alternative to SourceTree would be something like TortoiseGit or the many browser source control options available. In this video, we will be using Git with Bitbucket and SourceTree, mostly to have a degree of security and for ease of access by your team members. GitHub by default is all public, so anyone can access your projects, which is not great for making games. The Bitbucket account you make by using SourceTree is not, which is better. However, if you are already using different software or Git repositories, you can apply the same ideas described in this video. We can start directly by installing SourceTree, as it requires you to create an Altasian Bitbucket account or asks you to register an existing one during the installation process. You can actually use SourceTree with a GitHub account or even with Mercurial, but that gets a little bit more complicated and is not covered in this video. When you have registered your Bitbucket username during the installation process, you will be able to sign into SourceTree using your Bitbucket details. Doing so will mean you have configured SourceTree to look at your new Bitbucket account by default for creating repositories. This will typically require an authentication process and is done by default, so you have a location to start creating repositories remotely. Alright, so why do we use Git, Bitbucket and SourceTree to manage source control? In its simplest form, it's so we have a remote or external location where we have backed up our stuff. In its more complex form, it's so that we have that element, but we also have a system in which multiple people can access and interact with the project in a relatively harmonious and simultaneous manner. Think version control amongst a team with some assurance that problems can be retracted. By default, most software development tools, including Visual Studio and Unity, do not do this. Mostly because they don't have to. However, having it happen is obviously very useful. So the core of any Git project, whether it's a Hello World Python project or a full Unity-made video game, is the repository. Typically, this will start life as a local folder on your computer, usually the folder that stores your project at its top hierarchy. For a Unity project, that's the folder that has the assets, project settings, etc. next in line. Now, you don't need to follow this model. You can in fact make a repository have multiple projects within it, but it starts making less sense the more you do. So it's kind of safer to think of a repository as your project folder for now. So let's make this super simple. To start, let's create an initial repository by going to Create and selecting a destination path for this local repository, i.e. on your computer, giving it a name. Do note that repositories with Git are case and character sensitive, so don't use spaces or capitals if possible. If you know you will require a remote repository as well, which you typically will, it's the point of the software after all, you should also create the repository on your remote account. When you create a new repository, it will generate it both locally and remotely. Importantly, this process sets up the local and remote directories to interface with Git, typically via the use of a Git file in the associated directory. You will interface with the local version and update the remote version when you deem necessary. To set up a Unity project within this repository, we can now either copy an existing Unity project into the local folder, or create a new Unity project within it. If you are needing to access a remote repository from a different location, let's say at university, you will then need to clone the existing remote repository to create a new local one. Cloning your remote repositories is easy enough, but if you are working in a group or accessing a shared repository, typically called a project in Bitbucket, you will need details that are shared amongst your group. You can collect the address of your repositories and projects via logging into Bitbucket directly and copying the git clone command. Before we move any further, it is important to bring up two things: Gitignore and folder structure. Gitignore is a file that you drop in your Git repositories that instructs the software to ignore certain files and folders. As we are dealing with Unity-made games, we have a large number of files that A, get generated randomly all the time that can be ignored, example the library folder and meta files, and B, potentially have files that do not change for large periods of time, typically art assets. For the moment, let's deal with the former issue. The deal with this is that we put a gitignore in our parent directory. This file is a text file with instructions that you can customize. Generally speaking though, a generic Unity gitignore file will do a lot of the work regarding keeping your repository small. You can find one easily enough online to employ. Additionally, as you are potentially going to be working on your projects with a team, it is important for you to set up a folder structure that is agreed upon for all members. Within your assets folder, you should have a structural plan for where content will be placed, particularly regarding scripts. You should ideally have this conversation before project development unless you want to encounter horrors. Something like the following folder structure makes sense for the context of a final year project, but you should adjust it to what is relevant to your actual project. So let's say you have your repository set up locally and remotely and you have made some adjustments to your Unity project. Let's say for the sake of argument that you have created a new script or even edited an existing one. When you open SourceTree, you will notice that the software has picked up these changes, declaring them as unstaged files. To push any new or adjusted content to your remote repository, you must first stage them. When files are staged, you have the capacity to review any potential conflicts before committing them to the online repository. It is considered good practice to add a small comment for every major commit you make for the sake of effective record keeping. When you are ready, you can then commit these changes. To actually upload these changes, you must perform one final step, however, pushing. The act of pushing content to the online repository is where these changes will be saved online. Simply committing to a push does not change your online repository at all. So to do this, we push our changes onto our repository, usually selecting the branch closest to our developmental changes. In this case, we have only the master branch or base directory, so we push to the remote directory directly. Assuming everything works correctly, indicated by a lack of errors and a green progress bar, we can easily check the status of our repository by looking at it through your Bitbucket account in a browser. Here you can see that we have our new script appearing correctly. Finally, let's talk about pulling. Pulling will occur when you or someone else has committed a push and updated the online remote repository. To update your local repository, you must pull that new information. SourceTree will typically detect when there is a data mismatch, indicating the need to pull data from your online remote repository. Doing so should basically update your local repository to whatever your online remote repository is. Simple stuff, just make sure you actually pull the data correctly before working on your project. First and foremost, you can mostly use Git and SourceTree without the need to branch and merge, assuming your group communication is good enough. So, if branching and merging seems complicated, avoid it. However, one of the primary features of source control software is the ability for users to work on not only different content simultaneously within the same project, but potentially experimental aspects of it as well. Say you are one of the programmers on your team and you need to work on a new jumping mechanic. Locally, you can first perform what is known as a branch of the project, effectively identifying it as work in progress. This branch will be uniquely identifiable from the master branch, even if you commit and push it. Other project users will have the option to pull from this branch or continue pulling from the master branch. Perhaps multiple people need to work on this derivative branch simultaneously. The branched version of the repository now allows you to make changes to the project with a greater degree of freedom. Perhaps you need a new class or changes to existing controls is necessary, whatever. Changes made in a branch exist only in the branch, even when pushed remotely. Committing and pushing branches will work the same. However, let's say you have worked on something and it is quite successful. Some files, namely scripts, were adjusted in the process. You wish to merge these changes with the existing project. The merge process will allow you to review potential conflicts and eventually allow you to push working changes onto the main branch, assuming those conflicts are actually dealt with. Now you can identify if you are using the master or branch version of the repository via the indicators in the UI. A successful merge will indicate that you are using the master or root branch once again. So this process can be a little complicated even with minor changes occurring. My general recommendation is not to do too much branching and merging initially, especially in a group project, until you have some familiarity with the software at hand. The last thing you want to do is accidentally merge a conflicted repository branch with your master repository. Although with source control even these occurrences are quite reversible. So, in addition to these tools, it should also be known that there is a plugin for Unity that directly allows you to perform most of these operations within Unity itself. Although it is still experimental and not as customizable as using something like SourceTree, you can still connect to it, say with your Bitbucket repository easily enough. It's possible that depending on your preferences or machine, a combination of SourceTree and plugin in tandem may suit different team members for different purposes. As long as the remote repository is healthy and maintained, various commits and pushes from different technologies won't really make a difference. So, my recommendation when it comes to source control while using Unity is to first and foremost experiment with the setup and options, if only to increase your familiarity. Do this sooner than later. The last thing you want to have happen is misunderstandings in your most important projects at QUT, resulting in unnecessary problems or even unexpected loss of data. Take the time to learn it correctly and you will be just fine.